Will our vast and seemingly endless universe come to an end? Is it inevitable? Is it just a matter of time? What if everything in the universe, every brilliant star, every black hole, galaxy and subatomic particle, from neutrons, protons and electrons to quarks and neutrinos, were slowly edging towards a lifeless oblivion? An oblivion, not in the form of a colossal end like the Big Rip or violent rebirth like the Big Crunch, but a slow crawl to becoming a cold, lifeless, black abyss. This scenario is called the Big Freeze, a slow, silent fade, a quiet end to everything in the entire cosmos. It's a universe that simply runs out of energy, winding down over unimaginable eons until nothing remains but cold, dark, empty space. Ever since the Big Bang, the very fabric of spacetime has been expanding at a rate that is faster than the speed of light, carrying galaxies away from one another at an alarming rate. The arrow of time is forever moving forward, relentless and unfazed, and if the Big Freeze is the fate of our universe, that arrow is not leading toward an explosion, but toward an eternity of silence. In this scenario, everything, galaxies, stars, planets, and even the very atoms that make up reality, are slowly being stretched apart, cooling down, and losing all ability to sustain energy. A future where time itself is stripped of meaning, where the cosmos is nothing more than an empty void, expanding forever into absolute oblivion. At first, scientists believed the expansion of the universe may slow down over time, even reverse, leading to a catastrophic collapse known as the Big Crunch. But then, in the late 1990s, astronomers studying distant supernovae made a shocking discovery. Not only is the universe expanding, but that the expansion is accelerating, forcing galaxies apart, preventing even gravity from pulling them back together. This unknown force is known as dark energy and makes up roughly 68% of the total energy in the universe. It remains one of the greatest mysteries in physics, driving space apart at an ever-increasing rate. If dark energy continues to drive this expansion, galaxies that are visible to us today will drift farther and farther apart, their light stretched until they become too distant to ever be seen again. Eventually, the observable universe will shrink to the point where nothing outside of our own local group of galaxies is visible to us. Future civilizations will look up at the night sky and see nothing beyond the stars of their own isolated galaxy. The once vast cosmos will appear empty, as if no other galaxies had ever existed. But as space expands, it also cools. This is a fundamental law of thermodynamics. As energy spreads out, it becomes more diffuse and temperatures drop. Stars that burn brightly today will one day exhaust their fuel, becoming white dwarfs, neutron stars, or even black holes. The once great furnaces that lit the universe for countless billions of years, forging elements and sustaining planets, will one by one flicker and eventually die. In 1 trillion years, the last of the near-immortal red dwarf stars will finally fade, along with white dwarfs that no longer have nuclear reactions to sustain them, eventually becoming black dwarfs, dead, lifeless and void of any energy. The entire cosmos slowly cools with dead, cold, lightless remnants of stars, floating endlessly through space, leaving behind a universe without any light and without any heat. The cosmos, once ablaze with an endless expanse of stellar brilliance, will descend into an era known as the Degenerate Age, where the only thing that remains are the cold, lifeless husks of trillions upon trillions of dead stars. But what about black holes? Will they survive the brutal emptiness of the Big Freeze? Despite their awesome presence, nothing, not even black holes, will survive. Through a process called Hawking radiation, they will slowly evaporate over an unimaginable time span, trillions upon trillions of years, leaking energy, particle by particle, into the void until they, too, vanish. For a typical black hole, this process will take 10 to the power of 100 years, or what is also called a googol, a number so large that it defies human comprehension. But eventually, even the most massive black holes will dissipate into nothingness, releasing their last whisper of energy into an already frozen universe. And when the last black hole disappears, the universe will be left with nothing but the faint, lingering glow of background radiation. Heat spread so thin that space itself will hover just above absolute zero, the coldest temperature possible. An endless black void forever at rest at -273 degrees Celsius or -459 degrees Fahrenheit. All meaningful interactions cease. There will be no more galaxies, no more planets or stars, and no more life. Even atoms themselves will decay over vast stretches of time, breaking down into fundamental particles, drifting endlessly through the void. The universe will enter the dark era, a time when entropy has reached its maximum and no energy remains anywhere in the entire universe. It will be a cosmos of silence, where time continues but absolutely nothing happens, an eternal graveyard of a once vibrant, awe-inspiring existence. The most unsettling thing about the Big Freeze is not just that everything dies, but that nothing ever happens again in the entire universe. In the Big Rip, space itself is torn apart in a violent end with a runaway expansion that ceases to slow down. In the Big Crunch, there is at least the possibility of a new beginning, a rebirth from utter destruction. But in the Big Freeze, there is no final moment of time, no reset button, no rebirth. Time continues, but in a universe where there is no energy left to do anything. A universe where existence has become nothing more than an eternal, endless void. Could anything escape the lifeless fate of the Big Freeze? Some physicists speculate that advanced civilizations may find ways to harness the last remaining energy of the universe, finding ways to stretch their survival almost indefinitely. Others theorize that if the fundamental laws of physics allow, new Big Bangs could be spawned, seeding fresh universes within the remains of old ones. But these are purely speculative ideas, far from anything science can accurately predict. What we do know is that if the Big Freeze is the true fate of our universe, then everything we know is temporary. The stars, the galaxies, the very building blocks of matter, all of it is dying in a slow, unstoppable drift toward nothingness. This is one of the possible final fates of our cosmos, the Big Freeze. We hope you enjoyed our exploration into the end of the universe, and we invite you back for our next episode of